Hi, and welcome to the first video in Chapter 5. This is Section 5.1. We're going to be using fundamental identities. We're going to do a bit of a factoring review because we need to review some of our factoring methods before we simplify. We're going to go back over the trigonometric identity sheet. We're going to be using identities to evaluate a function. We're going to simplify trigonometric expressions and verify trigonometric expressions. The goal of this section is to improve your algebra skills, to improve your abstract algebra thinking, and to improve your understanding of trigonometric identities so you can apply them in calculus. Many of you are going on to calculus, and this section will help with that. So here are some common ways to factor. We're going to take a look at common monomials, the difference of two perfect squares, and product sum. We're going to go over all of these. So if you have two monomials, something like this, something that doesn't really product sum well, you take a look at what's common. So what variable is it common in x minus y squared x? And you would say the x is in common. So what you're going to do is you're going to factor out or divide out the x. And when you divide out the x out of both terms, we end up with 1 minus y squared times 1. And I'm not going to put the times 1 because it's just y squared. So you end up with x times 1 minus y squared. That's in algebra. In trig, you might have something like this. I have cosecant of theta minus cosine squared times cosecant. So what's in common is the cosecant of theta. And if I factor that out by dividing both of them by the cosecant, because you got to be fair, you can't just factor out of something, just one of them, you get 1 minus cosine squared theta times 1. So you end up with cosecant theta times 1 minus cosine squared theta. Looking at the difference of two perfect squares, here I cannot factor anything out and I cannot product sum. I might have two perfect squares and a difference of them. So if you remember with two perfect squares, you can write it like this. I have x, so I can write x here and x here. Minus 1 plus 1. So hopefully from Algebra 2 you kind of remember the plus minus. This is the difference of two perfect squares factoring. With trig, it would look like this. This is a perfect square and this is a perfect square. So this would be sine theta minus 1, sine theta plus 1. Then next we have product sum. All right, so product sum, let's see, product sum and the numbers. All right, so 1 times negative 12 is negative 12. And the sum is this b value right here, negative 1. So what multiplies to give us negative 12 but adds to give us negative 1? I think 4 and 3, and then negative 4. So negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. So we have x squared, keep the first term. Now we're going to replace this with negative 4x plus 3x minus 12. So then we're going to group, and here's where we factor out a common monomial. In this first set, I have x I can factor out, and I'm left with x minus 4, plus here I can factor out a 3, and I'm left with x minus 4. So then I have x minus 4 that I can factor out times x plus 3. That's what's left over. So here's what it would look like using trig functions. Same thing, you would run product, sum, and your numbers. Product is 1 times negative 12. The sum is negative 1. Again, we're at negative 4 and 3. So cosine squared theta minus 4 cosine plus 3 cosine minus 12. We're going to factor by grouping. Here, the common thing we can take out is a cosine, and you're left with cosine theta minus 4. Here we can take out a 3, and we're left with cosine theta minus 4. What's left over is cosine theta minus 4 and cosine theta plus 3. This part right here, this part of factoring, gets very useful in section 5.3, so that's why I'm showing it to you now. And let's review your identities. This is the identity sheet that you're going to be given. We have our general equations. So sine theta is opposite over hypotenuse, or y over r. Cosine theta is x over hypotenuse, or sorry, getting those mixed up. Adjacent over hypotenuse, or x over r. And tangent theta is opposite over adjacent, y over x. And we have our cosecant, which is our reciprocal, hypotenuse over opposite, r over y. Secant is our reciprocal cosine. That would be h over a, r over x. And cotangent is our reciprocal of tangent, adjacent over opposite, x over y. All right, the reciprocal identities you should know. Let's start with sine. Theta is 1 over cosecant. Cosine theta is 1 over secant. And tangent theta is 1 over cotangent. Cosecant theta is 1 over sine. Secant theta is 1 over cosine, and cotangent theta is 1 over tangent. We will give you the cofunctions. You do not need to have those memorized for calculus, so you guys can have the cofunctions, just know how to use them. Even and odd identities. All right, so the sine of negative theta is equal to the opposite of sine of theta, because it is an opposite function. Cosine is an even function, so it's just positive cosine. And tangent is an opposite function, so it's the opposite. All right, so cosecant of a negative theta, since sine is opposite, cosecant, its reciprocal, is opposite. Secant is even, so it's just the secant. And cotangent is an opposite function because tangent is opposite. Quotient identities. So the tangent of an angle is the sine over the cosine, and the cotangent of an angle is the cosine over the sine. And let's not forget our Pythagorean identities. We're going to take a minute here because these help us so much. Sine squared theta plus cosine squared theta equals 1. Rearranging, let's see, sine squared theta equals 1 minus cosine squared. So all I did was subtract over the cosine. Cosine squared theta equals 1 minus sine squared. Very, 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 very important to know these three. If you can do these three, the other ones are pretty easy. All right, if I divide all of this by sine, all right, this would be 1 plus cotangent equals cosecant. And if I divide everything by cosine, we get tangent plus 1 equals secant. All right, and we can rearrange these as well. So if you would like, we could do, let's see, cotangent, oops. I'm sorry, these are squared. I apologize. These are squared. Cotangent theta equals cosecant squared theta minus 1, and 1 equals cosecant squared minus cotangent squared. That might come in handy. Here we have tangent squared theta equals secant squared theta minus 1, and 1 equals secant squared minus tangent squared. So I'm just taking certain things over to the other side. So, for example, here I took the 1 over, so I subtracted the 1 over to the side and just got cotangent by itself. Here, I again subtracted the 1 over and got tangent by itself. All right, so now that we have our identity sheet, it's complete. It's really, really, really helpful to know these. So I'm going to be referring to the sheet quite a bit. All right, example 1. So in this example, we are going to evaluate the 6 trigonometric functions given some trig values. I'm going to be using the general trigonometric functions to help us do this, and I'm also going to use a picture to help us do this as well. So I know the sine is 0.55, and I know cosine is less than 0. So I'm going to go ahead and start with a picture so I get a nice visual. So I'm going to draw a picture over here. All right, sine is positive. That means the y values are positive, which means I am up here in quadrants 1 or 2. I just want to back up a little bit. This x right here, don't get confused by that. It's just theta. We just used x in this case. So it's sine theta, cosine theta. Don't worry about the variable that they put in there. Theta is just fine. You can use x, you can use theta, you can use a happy symbol, whatever it is that works for you. Sine is positive, so we have to be in quadrants 1 or 2. Cosine is less than 0. Cosine is negative. All right, remember, all trig functions are positive here, so we have to be in quadrant 2. So our theta is right here. And we know sine is 0.55. Well, if we had a fraction, boy, wouldn't this be easy? Well, we do. You can take any number and put it over 1, and boom, there's a fraction. So we know the sine of theta is 0.55 over 1, and we know this is opposite over hypotenuse. 0.55 over 1. Now we can find cosine. We can find cosine by doing Pythagorean identity, or sine squared plus cosine squared equals 1. Pretty easy. So let's see. We have a squared plus b squared equals c squared. So let's go ahead and do a squared equals 1 squared minus 0.55 squared. And let's see what we got here. A squared equals, remember a is this right here, and it's going to be negative. That's the biggest problem with this. You guys are going to do the math just fine. But when it comes to doing the right sign, plus or minus, you get tripped up. So 1 minus 0.55 squared gets us 0.6975. Now this is a squared. We want just a. So taking the square root of that, we get plus or minus 0.835. And we're going to use the negative. Negative 0.835 over 1, because it's adjacent over hypotenuse. From here, it's really not too bad. We've got tangent theta. We can do sine over cosine. We can do 0.55 over negative 0.835. So 0.55 over that, we get negative 0.659. And the rest of these are just the reciprocals. Cosecant theta is, let's see, 1 over 0.55. Secant theta is 1 over negative 8.835. And cotangent is 1 over negative 0.659. I'll go ahead and calculate those real quick. So 1 divided by 0.55 is, 0.818. 1 divided by 0.835 is negative 1.198, and 1 divided by 0.659 is negative 1.517. So there are your 6 trigonometric values just using SOHCAHTOA, using a triangle, using the basic trig identities. All right, so here's your Edpuzzle question. Evaluate just the cotangent of this function. So there's a little bit of work you need to do. You need to figure out which quadrant you're in. You need to figure out what the sine is, and then you're going to tell me what the cotangent is. So this is going to take you a minute or so. Give it a try. I think you guys can do it. All right, so cosine is positive. That means we're over here in quadrant 1 or quadrant 4. Sine is also positive. So I gave you guys an easy one. We're in quadrant 1. And we know cosine is 0.72 over 1. So we'll make this a. So a squared plus 0.72 squared equals 1 squared. So a squared equals 1 minus 0.72 squared. So 1 minus 0.072. Get 0.482. Take the square root of both sides. We get 0.694. So we have sine is 0.694 over 1. Cosine is 0.72 over 1. And we know tangent is sine over cosine. Cotangent, I'm going to use cosine over sine. All right, so 0.72 divided by 0.694. And you should have gotten 1.037. And that's the answer I was looking for. So hopefully this one wasn't too bad. We did a little bit of this kind of stuff way back in chapter 4. Hopefully this wasn't too difficult. So now let's move into the more abstract. We're getting away from the numbers and we're moving into just manipulating, getting really good with our algebra. Sometimes we have expressions like this, secant times cosine, or tangent times cosecant, and we want to break things down. This is two trig functions. Could I boil this down to one trig function? So, do secant and cosine have anything in common? Well, let's take a look at our identity sheet. Look at the reciprocals. Secant is 1 over cosine. I'm not going to touch this cosine. This cosine is just going to stay as is. I'm going to substitute secant for 1 over cosine. So instead of calling it secant, I'm calling it 1 over cosine. These two things are the same thing. I'm going to leave the cosine by itself because look what happens. Since we're multiplying, this cancels and you end up with 1. So secant times cosine is really just 1. How much more simple can that be? This is why we do this. We get things that are really complicated. We boil them down to something very simple. Let's try tangent and cosecant. I'm going to break things down into sines and cosines. So tangent is sine over cosine. And cosecant is 1 over sine. Since I'm multiplying, these signs cancel and I'm left with 1 over cosine. If you don't like that, the way I did that, sine times 1 over cosine times sine. Maybe you might see it better that way. You're left with 1 over cosine. 1 over cosine is secant if you take a look at our identity sheet. So tangent cosecant really is just secant. So let's play around with factoring things out. That's the next thing. In this expression, can we factor something out? Is there something in common between this monomial and this monomial? And you should see that it's the cosecant. So if I factor out the cosecant, I got to factor it out from both. I got to divide it out. That's what factoring is. I'm left with cosine squared theta minus 1. So this becomes 1, that becomes 1. Can't forget your placeholder. So I'm going to leave this here, cosecant theta times cosine squared theta minus 1. We're just going to pause here with this one. I just wanted you to see what factoring out looks like. Next, you can use your very important trig identities. Those are so helpful. Whenever you see a trig function squared in a 1, use your VIPs. So let's take a look at our very important Pythagorean trig identities at the bottom of our page. What is 1 minus cosine squared? You should see sine squared. 1 minus cosine squared is sine squared, so I'm making a substitution. Sine squared and cosecant are related. You should see in your reciprocals that cosecant is 1 over sine. And if I multiply these, I'm left with sine times 1, or just sine. And let's take a look at this one. All right. This is another one that we need to break down into sines and cosines. There's nothing for me to factor out. Cosecant, cosine, and cotangent are all different trig functions, so there's no factoring anything out. I can't use a VIP because I don't have anything squared or a 1, so I'm going to break things down into sines and cosines. So this is 1 over sine, according to my reciprocals. This is just cosine over 1. And cotangent is cosine over sine. All right, I have 1 over sine minus cosine times cosine, which is cosine squared. 1 times sine is sine. So I'm multiplying across. Knowing my algebra, I'm just multiplying across. Look, I have common denominators. Awesome! So my common denominator is sine. And in the numerator, I have 1 minus cosine squared. All right, look at your Pythagorean identities. What's 1 minus cosine squared? It's sine squared. So many of you are probably saying, well, where'd the 1 go? Where'd the cosine squared go? Look at your identities. 1 minus cosine squared can be sine squared. They're the same thing. They're equal to each other. So now I'm left with sine squared over sine. Well, I'm going to break this down for you. Sine squared is sine times sine over sine. So one of the sines cancels in the numerator. We're left with just a sine theta. Moving on, let's take a look at common denominators. This is going to be a part of your Edpuzzle question, but don't worry, I'm going to walk you through this. When you do not have common denominators like we had in the previous example, what we can do is make common denominators. So in this denominator, I have 1 minus cosine. So I'm going to multiply that to this guy. 1 minus cosine, 1 minus cosine. Over here, I have 1 plus cosine. So I need to multiply by 1 plus cosine. So I'm making common denominators. Just like if I was trying to add 1/2 to 1/7. I would have to multiply by 2 over 2 and 7 over 7. All right, let's multiply across here. 1 minus cosine theta times 1 is 1 minus cosine theta. Now let's do the bottom multiplication. 1 minus cosine times 1 plus cosine. We're going to do that off to the side here. So 1 minus cosine times 1 plus cosine. This is a difference of a perfect square. So first, outer, inner, and last. So I'm left with 1 minus cosine squared. Well, hey, what's 1 minus cosine squared? We just did this twice. It's sine squared. Yay! All right. So now let's take a look at our next fraction here. Plus, change colors on me, I apologize. All right, again, 1 times 1 plus cosine is 1 plus cosine. Now look at the denominator. It's the same thing. It's sine squared. We already did it. So now we have common denominators. So let's make our common denominator sine squared, and we have 1 minus cosine plus 1 plus cosine. All right, so what can we get rid of in the numerator? I have 1 minus cosine plus 1 plus cosine. What can cancel? And you should see that the plus cosine and the minus cosine can cancel. And I get 1 plus 1 over sine squared theta. 1 plus 1 is 2 over sine squared theta. And here's your Edpuzzle question. What can this simplify to? Let me give you a little bit of a hint. 2 times 1 over sine squared. What can this simplify to? Go. And if you got 2 cosecant squared theta, you are right. The 1 over sine squared can simplify to a one trig function cosecant squared. All right, let's take a look at example 6. Let's break things down. This is called verifying. So here's how verifying works. See this equal sign? We're going to put a barrier or a river here. I can manipulate this left side however I want, and I can manipulate the right side however I want, but I cannot multiply, divide, do anything across the river. Please do not go back and forth. What we're trying to really prove is this side the same as this side? So is secant minus tangent times sine the same as 1 over secant? That's what we're going to try and find. My hint here is to break things down. I cannot factor anything out. I can't use a Pythagorean identity, so it's very similar to what we've been doing, breaking things out. So secant is 1 over cosine. Tangent is sine over cosine times sine. All right, we're saying this equals 1 over secant. All right, 1 over cosine minus, all right, this is sine over 1, so sine times sine is sine squared. Cosine times 1 is cosine, and this is supposed to be 1 over secant. All right, we have common denominators, lucky us. So our common denominator is cosine, and 1 minus sine squared in the numerator. This is going to be 1 over secant. So again, I have not crossed the river here. I have not taken anything from the left side to the right side and vice versa. 1 minus sine squared. Look at your Pythagorean identities. What is 1 minus sine squared? And if you got cosine squared, you're right. All right, 1 over secant. All right, so we can cancel. One of these cosines can cancel with this, and I'm left with cosine theta equals 1 over secant. Look at your reciprocal identities. What's 1 over secant? It's cosine. So the only time I ever touched this side was to manipulate it to make it cosine to look like cosine. So that's all there is to this. It's almost like a puzzle you're trying to put together. You're looking at different identities and trying to figure out, well, if I substituted X, Y, or Z in, will it make things cancel, essentially? So let's try the next one together. This is our last question. First thing we're going to do is we're going to make a common denominator. So here I have cosine, here I have cotangent. So I'm going to multiply by cotangent over cotangent and cosine over cosine. Okay, so let's take this slow. Cotangent secant divided by cotangent cosine minus tangent cosine over cotangent cosine equals 1. Here's our river. All right, we have common denominators. We have cotangent cosine, and the numerator is cotangent secant minus tangent cosine equals 1. All right, so I made my common denominators. There's nothing I can factor out in the numerator. Nothing I can factor out in general because I've got a cotangent, a secant, a tangent, a cosine, a cotangent, cosine. There's nothing squared. I have to start breaking things down into sines and cosines. So here we go. Cotangent can be called cosine over sine. Secant is 1 over cosine. Minus tangent, which is sine over cosine, times cosine. In the denominator, we have cosine over sine, because that's cotangent, times cosine, equals 1. All right, let's see what we can do. These cancel, and these cancel. Those combine. Okay, so here we end up with 1 over sine minus sine, all divided by cosine squared divided by sine. So cosine times cosine is cosine squared. Sine times 1 is just sine. Oh boy. Okay, this is going to equal 1. Okay, so let's see what we can do here. In our numerator, here's one thing we can do. Let's see. There's a few ways we can progress from here. One thing you can do is make common denominators in your numerator and keep going from there. Another thing we can do is we can do the keep, switch, flip. We can keep the numerator and switch and multiply the denominator and see what happens. And that's what I'm going to do. I'm going to keep the numerator, 1 over sine minus sine over 1. times, now let's flip the denominator, sine over cosine squared. Okay, and this is supposed to equal 1. All right. So let's go ahead and multiply this in. We have, so I'm going to multiply it into the first one. We have sine times 1 over sine cosine squared minus sine squared, because sine times sine, over cosine squared equals 1. Oh, look what cancels. This cancels, and I have 1 over cosine squared minus sine squared over cosine squared equals 1. I have common, there's two ways you can do this. I have common denominators, so I can write 1 minus sine squared over cosine squared equals 1. What's 1 minus sine squared? It's cosine squared. And I end up with 1 equals 1. Here's your Edpuzzle question. There's another way to solve this. What is 1 over cosine squared? What else could you call that? And what's sine squared over cosine squared? What could you call that? And why does it equal 1? So that is your Edpuzzle question. Take a look at your identities. What's 1 over cosine squared? What could you substitute that for? Minus sine squared over cosine squared. Look at your identity sheet. We just did this. What's sine squared over cosine squared? What could that be? And why does that equal 1? Okay, 1 over cosine squared is secant squared. And sine squared over cosine squared is tangent squared. This is a VIP. So this is one of the VIPs. Secant squared minus tangent squared equals 1. There you go. So right here you could have been done right at this point. Instead of doing 2 extra steps, this would have been the fastest step. Secant squared minus tangent squared is 1. So 1 equals 1. All right, so that's it for section 5.1. 5.2 is just a continuation of this. We are going to get a lot of practice. So this, I don't expect anybody to be a master of trig identities right now. This is difficult. This takes time to learn. Cut yourself some slack. When you get into class, feel happy. Other classes in the past have had to do this by themselves. We're doing problems together. So we're going to, I'm going to try and walk you through them till you get to the point where you are comfortable doing them on your own. So I'll see you guys in class. Bye.